This is 3.2 linear functions, second try, recorded at once. And for some reason, 1 second of the video posted and I couldn't recover anything else. So here we go again. This is page 66 to 68 in your journal. Linear functions. So we've got right up here, linear equation and two variables. They're talking about x and y. Usually they're both there. Occasionally only the y is. I'll show you that a little bit later. Can be written in the form y equals mx plus b. That's this over here. M and b are constants. Constant means they're going to be numbers. One of those numbers can be 0 or 1. Sometimes those numbers don't show up. Shy numbers, as I call them. Linear function can be written as an equation in two variables. A function whose graph is a non-vertical hint. What word is in there that they're trying to tell me to put in? You got it right. Don't forget you can use that pause button to try to answer questions yourself first. In there, we're trying out the video cam here. I don't think it works because my head is down most of the time looking at this. A function whose graph has a constant rate of, we talked about this the other day, the new word for graph, rate of change. Okay. Nonlinear function does not have a constant. Get it from the last one. Pause it. Rate of change. The graph is not a straight line. So if it's a linear function, it's a straight line. Pretty obvious. Solution to a linear equation in two variables, an ordered blank x comma y, which makes the equation true. Again, use that pause button. You got it. Pair, ordered pair, we call that. Discrete domain. So domains are our x values or inputs. Discrete, there's going to be gaps, as I mentioned here. Only certain numbers on an interval. So I'm just reading through this part here. Only certain numbers on an interval. Example, the number of free throws made in 5 shots could be 0, 1, 2, 3, 4, or 5. Any of those. You can't make 1.3. You can't make 4.7. Got to be those numbers. There's gaps between the possible data points. Continuous domain. Again, that's your set of, you got it, x values. All numbers in an interval. Example, number of minutes to complete a puzzle could be 1 to 5. It might be 1 minute 32 seconds. 1 minute 32.4744852 seconds. It can be any number in that interval. And that's discrete. We'll see that more on this next page. So this shows us multiple representations here. The multiple representations, big thing in math nowadays. Different ways to show the same thing. So all these statements, we've got words, equations, input, output table, mapping, and graph. They are all the exact same thing. And output is 3 more than the input. That's in words. Y equals x plus 3. Y is my output, x is my input. I'm adding 3 to it. That's how I know it's going to be, the output's going to be 3 more than the input. I add 3 to it. You can see it in the table. 2 is 3 above negative 1. 3 is 3 above 0. 5 is 3 above 2. The mapping just maps it. Negative 1, just using the arrow, goes to 2. You can see the same pair there. 1 goes to 4. You can see the same pair there. And then these are just graphed over here. So you've got the negative 1 and the 2. Negative 1, 2 right there. 2, 5. 2 is my x. There's my 5. There's my graph. They drew the line between it. That line isn't always between them in this case. We'll usually tell you when it's not. So note, little practice here. An output is 7 less than twice the input. Use that pause button. Try to write that equation in here. Okay, bet you most of you got pretty close on this. So minus 7 less than something is going to be minus 7. You got to be careful about that. 7 less than, I got to take away 7. then twice the input, that's twice x, 7x minus 7. Can't get that minus nice and centered, close enough. And that's that one. Here they got a nice picture of the discrete and continuous. Notice I mentioned here with the gaps between 1 and 2, you've got a gap. Can't be anything in there. Between 2 and 3, you have a gap. That's what they mean by only certain numbers on the interval. So on that same interval here, this goes from 1 to 5, but there's no gaps. It can be any number in that interval. It can be 3.7. It can be 2.1. It can be 4.832 on those. And let's get to the problems. This is going to be one of the easier sets of problems you get done because I've got to explain most of them. I wish they had another page of problems here. So exercises 1 and 2, linear and explain it. Always explain it, kids. That's the important part. You can't explain it, you're just guessing. Number 1 here. I don't know why those aren't circled. Got to do it. Number 2. Hey, this is a straight line. That means it's linear. Let me write that bigger. The graph is a straight line. Is this a straight line? If it's not, it's nonlinear. If it is, it's linear. You got it. This one, I keep forgetting to mention this. You really should look in the book for this section. This is really brief on the examples in here. And it's even briefer on the practice since I got to use the practice for examples. So don't be afraid to take a look in the book and try some of those, what do you call them, monitoring progress problems to make sure you get these. We might even do a few of those in class. Now for this one over here, if the input has equal changes and the output has equal changes, then the function is linear. So we're going to look at number 4. I look at this. I've got a change of goes up 1, goes up 1, goes up 1. So all those inputs have equal changes there. My outputs, I went down 1, I went up 1, I went up 3. They're not equal. So this one is going to be nonlinear. My inputs and outputs have consistent gaps. The outputs do not. So that makes it not a function. Then do the same thing over here. Look at the gaps. Look at the gaps. These gaps are the same up here. If these are all the same down here, you've got yourself a linear function. This means there's one of each in the problem for the answer key. For this one, I got a note over here on it. Whoops. It can be written in y equals mx plus b form. You might know this is slope-intercept form. Note the little circle I have here. It can't have an exponent on that x except for 1, which we usually don't write. Is number 5 a function? Well, we can rewrite this. Try to rewrite it. Pause it. See if you can rewrite it as y equals mx plus b. Pause. You've unpaused. Y equals negative 2x plus 3. That's y equals mx plus b form. You're looking pretty good. Okay, so this is going to be it's going to be linear. Can write in y equals mx plus b form. And then I mentioned, if it's got an exponent on the x, it's not linear. Just take a look there. 7 and 8, we're just looking at continuous or discrete. So Geez, that looks more like this one. That's a straight line. That was continuous. So this is going to be continuous. So I'm going to say this is continuous. And then my domain, that's my x value, starts at 1, goes up to 5. So it's 1, 2, 5. And that's going to be inclusive because it includes the 1 and the 5. You've got the solid circle, so it includes those points. Over here, you've got gaps in there. What do the gaps tell you? We've gone over that before. Does gaps tell you continuous or discrete? And then, just like you saw me drawing the little lines down here, just draw the little lines down to get your x values, to get your domain. And voila, you are done. And we got our 15 minutes done in 11.